All right, so hopefully you had a chance to fill in all of the values from your calculator expressions and look a little bit more deeply at what exactly is going on with some of these values. Now I'm writing some of them just so that way we can quickly compare notes, because the idea is that we can look consistently at all the problems and say, okay, wait a minute, what's really going on here? As a reminder, and this may have helped for those of us who were on the cusp of making this connection, we're really saying that log of 100 is 2. It's almost like there's an implied equal sign there. In letter B, that log of 10 is 1, like there's an implied equal sign there too. In letter D, that log of 1 is 0, implied equal sign there. There are implied equal signs really between all of these log expressions and the box next to them. So if you think about logs the way we've been thinking about logs through this entire lesson, your brain naturally might have just gone exponentially and translated the log into an exponential something, meaning that question mark, that mysterious base, to the power of 2 must have given us 100 as an answer. That's how I would translate this log expression. And I know that that question mark squared must be 10. 10 squared is 100. So I can infer that that question mark probably was a 10. And let's see if that's true here. If the 10 really was the question mark, would that make sense exponentially? 10 to the power of 1 equals 10. Yeah, it would have worked. In letter C, if there was an invisible 10 there, 10 to the power of 4 is 10,000. That would have worked. And that would have worked in all of these problems. So the mystery is solved. That little invisible base really was 10, which means that when you see a log by default, like it just says log, either as a button on the calculator or in a problem that just says log, a log by default is a log base 10. The 10 is normally invisible. So if you see a log by default, it's not because it doesn't have a base. Every log has a base. It's because every exponent has a base. You can't just have exponents floating in midair. We can't write to the power of x equals 3 in question number 2. You have to have a base securing your exponent, giving it something to hang on to. Therefore, every log has to have a base as well. Every log has a base because it represents the base of the exponential expression. And if you don't see the base, that means by default it's a log base 10. So sometimes as you flip later into the packet, you're going to see that happen. For example, in question number 10, which is on the next page, you'll see a log question, kind of like letter D here. It just says log x. Well, there really is an invisible base 10 hiding in that problem. If they tell you the base, then you use whatever base they tell you. It's just worth noting that 10 is the default base. So that's something worth memorizing just to make sure that you have it. The default base is a log base 10. And if you don't see a base in a question, I'll highlight this just so you know. If you don't see a base in a question, the default base of all logs is 10. The reasoning for that is a little bit more interesting if you want to try to get into it, if you want to Google it or try to do a little bit of research on your own, but it actually boils down to a very simple principle. It's because when logs were originally created, when people were trying to solve exponential problems and realized they needed to create an opposite of an exponential to be able to do algebra, they picked base 10 because they figured the world should logically be on base 10. We have 10 fingers. We have 10 toes. The metric system is based on 10. 10 was actually a very logical choice for a base because so many of our early calculations were based on very easily accessible figures like fingers and toes. So the log base 10 is actually predicated on the idea that people really did count in a base 10 system. So the log was created first for the base 10 system, the system of counting on our fingers, and then it evolved over time to include other bases as well. So a little bit of math history there. The base 10 is intentional, and it's because we really do have 10 fingers. That's all. That's the reason. So now that you understand that a log by default is a log base 10, maybe some of these questions like number 4 will make more sense. Try question number 4, and if you feel like you don't quite get it, the next video will walk you through.